Welcome to my channel. Your tutor Mariam is here. It's the 60-second video of Introductory Physics 1 and the 24th video that I'm going to talk about the laws of motion. That is the fifth subject of Introductory Physics 1. In this video, I'm going to solve an example about two blocks that one of them held on top of the other one. So I'm going to find the force if two blocks moves together or one of them stay at the rest. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and look for more. You ready? Let's get started. So here I have two blocks A and B, and the coefficient of kinetic friction for all surface is 0.2. I need to find the magnitude of horizontal force if A and B move together, and for part B if A is held at the rest. Let's start with part A. I'm gonna draw the free body diagram. It says A and B move together, right? So I'm gonna assume A and B is like one block. So it's like I have a big block right here and they move together. So this one is like A and B, right? Because they're moving together. Now I have a force F that applied to this object, right? And now there is a friction force applying the other way, right? This one. So it's going to show it as Fk. This is the friction force. If the box moves to the left, the friction force is going to be to the right. One thing I like you guys to notice here is this part. Constant speed. So that constant speed means that V is constant, right? That means my acceleration is 0, right? This acceleration is the total acceleration, correct? So that's telling me my total F here gonna be 0 because F is equal to m times a, so that acceleration gonna be 0 and total F gonna be 0. Now let's go back to part A. So I'm gonna write the second Newton's law in x and y axis. Let's start with x axis. My total F in x axis gonna be equal to ma, right? But acceleration is 0, as I said, so that total F gonna be 0, right? So what I have then is gonna be F minus Fk, right? So that F here, and that's gonna be the friction force, right? So if this is 0, then my F gonna be equal to Fk, right? So what I need to find here is Fk. So what is Fk? Fk is equal to mu k times n, right? So I need to find the normal force here. For these two blocks, my normal force is gonna be this way, right? And also that's gonna be my weight, correct? But remember, this m is the sum of two m's, right? m1 plus m2 times g, correct? So let me write down the second Newton's law in y-axis. So F total in y-axis gonna be equal to 0 because there is no movement in y-axis. So n minus m1 plus m2, remember they're moving together, g equal to 0, right? So then n gonna be equal to m1 plus m2 times g, right? And it's gonna be equal to m1g plus m2g, right? And it's given in the problem. So I'm gonna substitute this one as A and B. So it's gonna be 2 plus 4, and that's gonna be 6 newtons, right? So my N is equal to 6 Newton. I'm gonna substitute it over here. So then my mu K gonna be equal to 0.2 times my n gonna be 6. So my answer gonna be 1.2 newtons. So that's gonna be my Fk, correct? And my Fk is gonna be equal to F. So my F also gonna be 1.2 newtons. This is the answer for part A, 1.2 newtons. Now let's look at part B. Part B says if A is held at rest. So it's like only box B gonna move, right? Let's see how many forces apply to box B. So I'm gonna draw the free body diagram for B. So what I have for B is like there is a box B and then there is a force applying here, right? There is a friction force only for box B, so I'm going to call it as FKB. Also, there is another force between A and B because this time A is not moving with B, right? So imagine I'm going to hold A, so it's not going to move. I'm going to pull B, right? So there is a friction force between A and B, correct? They're not moving together. So then there is a friction force is in the opposite side of the movement, and that's gonna be FKAB. Again, they're not moving together. So now let me write down the second Newton's law again. So my F total in x-axis gonna be equal to F minus FKAB minus FKB equal to MA, right? This is the total acceleration. And that's gonna equal to 0 because again, it's mentioned that box moves with a constant velocity. So it's gonna be equal to 0. Then my F here gonna be equal to FKAB plus FKB, right? And F in general is equal to mu n. So let's start with FKB. So I'm gonna write it down for FKB. That's gonna be mu times n. Now we have to be careful about n here, that normal force. Let's think about what is a normal force between A and B. So I have two blocks, one on top of the other one, right here, right? This is my A, this is gonna be my B, and I'm talking about this friction force right here. Normal force gonna be here. So the only normal force I need to consider is about object A, because this is a friction force right here between these two objects. So it's going to be FKAB, right? That's the friction force I'm talking about here. So the normal force is only depend on the blocks A. So that's going to be my mu MAG. My mu here is 0.2. My MAG gonna be equal to 2. So that's gonna be 0.4 newtons. So I have an answer for that. Now I need to calculate FKB. So here I'm talking about this friction force right here, right? But remember, I have another object on top, right, which is A. So the normal force here gonna be the normal force of both of these objects, A and B. So the whole thing right here have one normal force on top. And as it is not moving in y direction, then that n gonna be equal to mg, and it's like this is gonna be m1 m2 times g. It's gonna be the same things we calculate in the part A. And we already know the answer for that. but I'm gonna write it down again. So my FKB in y-axis gonna be, this is the total, this gonna be equal to 0. So my n minus m1 m2 times g equal to 0. Then my n gonna be m1 plus m2 times g, right? So then my n gonna be equal to m1g, m2g, and that's gonna be equal to 2 plus 4, gonna be 6. So now let me calculate FKB. So that's gonna be FKB. It's gonna be equal to mu times n. So my mu gonna be 0.2, my n is 6, so that's gonna be 1.2 newtons. So now I have answer for KB, I have answer for KAB, and I can calculate the F from this equation right here. So then my F gonna be 0.4 plus 1.2 equal to 1.6 newtons. And that's gonna be my final answer for part B. I hope you guys find this video helpful. If you like my video, hit the like button and subscribe. And I'll see you in the next video.